Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Noor Bazlan bin Muhammad Hasanuddin. My metric number is B0717107556. So this is for my lab test for the subject high voltage. But prepared for TS Dr. Zikri Abadi bin Baharudin. So for the first question, this is, and I will snipping tool. Snap this, copy, and I will open the pen, will paste. So basically pencil. Okay, basically the apparatus that will be used in this high voltage lab is the test transformer, measuring capacitor, grounding switch, charge electrode. Sorry, it's not charge electrode. I mean it's the top electrode, and then connection rod, connection cup, floor pedestal, and then lastly is the secondary part for CM. So this is all the part that we need to consider in order to run this laboratory test. So basically, test for transformer, which is the PZT current transformer, measuring capacitor, grounding switch. Grounding switch is the secondary device, which is the grounding part that will be used. Then we have the top electrode, which is the shape of the top electrode, like we call it scuba. And then we have the connection rod, which is made from the iron metal. Connection cup, which is the function of a connection cup is to connect between the PZT transformer and the connection rod. And then for the floor pedestal, the function of the floor pedestal is to connect between the measuring capacitor and with the secondary part of the grounding switch. And lastly, we have the secondary part, which is the function of the secondary part contain about 16 capacitor, which is capacitor. Okay, that's all for the first section. Okay, next I will explain about the section B, which is in section B I need to draw the electrical schematic diagram, which is that I already tick the component that I need, that component that will be used in this laboratory test. So firstly is the test transformer. Basically, this is my pen, and I will search it on Google, which is, I don't know if I can find the correct one. Test transformer Hafley. Okay, I will use this. So this is our test transformer, and I will snap this tool, copy, and I will paste on pen. This. Okay, then so for the schematic diagram, for this test transformer, which is I need to draw the test transformer. Yes, just like that, and the connection of the test transformer will be directly to the. Actually, we have 3 line, which is 2 line for the supply, and the last line is for the grounding purpose. So all of this line will be connected to our box of the frequency converter. So there is the schematic diagram, which is for the test transformer, which is in this schematic diagram, all of the line of the cable will be used about 2.5 mm square for the sizing of the cable. Okay, next I will proceed to second one, which is I need to explain about the measuring capacitor. So I will be snipping tool our measuring capacitor, which is this one, snipping, and I will copy image to paste here. So this is for the capacitor. So the schematic diagram for the capacitor is just like that, and the usual capacitor that we will use in the lab. So the value of the capacitor that will be used in this laboratory is 100 picofarad. So basically this measuring capacitor will be connected between the grounding switch, the secondary device for the grounding switch, and at the top of the measuring capacitor will be placed with the connection card that will be connected between the measuring capacitor and our test transformer. So okay, next then I will clear this. And I will proceed to the next one. So next one is our grounding switch, and I will find the grounding switch. So this is our grounding switch, the grounding switch, and this is the snipping tool, and I will copy this picture and paste to our pane. Okay, basically the grounding switch that will be connected between the measuring capacitor. So basically this is our measuring capacitor. So in this measuring capacitor, macam mana nak look at? Okay, measuring capacitor. So the grounding switch, which is like the device lah, that we connected. So basically the schematic diagram just like this, like the grounding symbol. So basically in the grounding switch we have the grounding rod, which is this grounding rod will be touched with our top electrode that will be placed in the top of the our measuring capacitor. So that's why this secondary grounding switch, secondary device of the grounding switch will be placed at the bottom of the measuring capacitor. This and we have the electrode, we have the grounding rod. So basically the grounding rod will be touched with our top electrode. So okay, just like that. So next I will explain the next component, which is the top electrode. So okay, this is our top electrode that will be used in the our lab. So I will copy this and will be paste on our pen. So basically this is our top electrode. So the top electrode, so just like I explained before, that the function of the top electrode is to reduce the corona, which is by tapping the grounding rod that attached with the grounding switch, our secondary device of the grounding switch, and will be touched to our top electrode in order to reduce the corona. So that's for our top electrode. Next I will explain about the connection rod. So basically the connection rod, let me find the connection rod. So this is our connection rod. This is, and I will copy the connection rod, copy and paste. So this is our connection rod. So the connection of the connection rod that will be connect between our test transformer. So this is our test transformer, and then we have the measuring capacitor. So the connection rod, this connection rod will be placed between the measuring capacitor and our test transformer in order to allow the connection between all the component happen. So in order to connect between the connection rod and our measuring capacitor is by using the connection cup. So this is our connection cup. Connection cup, copy and paste in here. So this is our connection cup, and just like I said before, that the function of this connection cup is to connect between the test transformer and our connection rod. So it will be placed like here. So actually the connection cup is to can connect like place like in the horizontal position, or we can also place in the vertical position. So next I will explain about the floor pedestal. So the floor pedestal, so this is our floor pedestal. Snipping tool, copy and I will be placed in here. So this is our floor pedestal. So basically this floor pedestal, uh, the the position of the floor pedestal is just like this, flip horizontal, no, flip vertical. So basically the connection of the floor pedestal will be placed bottom of the measuring capacitor. So this floor pedestal I will draw like this of the floor pedestal, which is this floor pedestal. This is for floor pedestal. The function of this floor pedestal is to connect between the our grounding switch, secondary grounding switch, our secondary grounding switch, and then also the purpose of this floor pedestal is to connect the grounding purpose, which is there will be the copper braided, which is the function of the copper braided is to act as the grounding or the earthing switching. So the copper braided will be connected in this point, and then at the uh, at the at this grounding switch, we have the top electrode, which is the top electrode will be touching with our top electrode, top top electrode. So this grounding rod will be touched with our top electrode in order to complete our grounding switching. So, and the last part is let me clear this screen first. The last part is, so I will explain about the secondary part for the CM, which is the CM is secondary, secondary, the secondary secondary. So okay, this is our secondary, and I will snipping tool, copy, and I will paste in here. So basically this is our secondary part for the measuring capacitor. We have the banana connector one, and the second one is the banana connector 2. So basically in the secondary part we have the a lot of the capacitor, which is 19 capacitor that will be connected in series connection. So and I will draw like this lah for the inner connection of the secondary part. Imagine that this capacitor have 19 capacitor. So 19 capacitor. So at the end of this line and this line, we have the banana connection, and this banana connector. Okay, banana connector, which is will be connect. One is the directly, which is the banana. I will draw like this lah. Okay, like this. So one which is the first one is the center point of the secondary part for CM is connect between directly to this one, to the first point of the banana connector, and the last one, the second one of the banana connector will be connected directly to the point, directly to the body of the secondary part lah, which is the purpose we do like this is for the safety method lah, and same method with the this end line, which is the end of this capacitor will be connected to the first part of the banana connector, and the last one will be connected to the body of the secondary part. So that is for the roughly of the external, roughly explanation for the second explanation for the secondary part for CM lah. And then about our the last part, for the last component that will be explained is our secondary part for the capacitor secondary part, which is the what we call the secondary unit for AC, which is the printed circuit board, which is, where is the circuit board? I will copy in our previous laboratory picture. Where is it? Okay, this is. So I will sweeping tool, copy, and I will be placed in here. So basically this is our secondary unit, which is the connection, or I mean the schematic diagram for this secondary unit of the capacitor, which is in this unit we have about 19 capacitor that will be arranged so all the capacitor will be arranged in series, which is we have 19 capacitor. Oops. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 and 19. So it will be connect each other, which is also have the supply either AC or DC, but for this lab will be use the AC in order to AC supply in order to connect between all of the capacitor that arranged in the series. So this is our supply AC and will be connect each other. So, and also we have the grounding method for the grounding purpose. So this is for our secondary part for the CMSC, and then I will explain about the next I will explain about the switching spark gap, as you mentioned that in this part. So I will be copy and search it on the Google, which is the what we call switching spark gap. So this is the switching spark gap. So, and I will be used in this picture. Copy, copy and paste. So this is our switching spark gap. So the schematic diagram for the switching spark gap, just like the varistor, which is like this, so and directly to the ground lah for the so like this lah. Okay, this is the schematic diagram for the switching spark gap, which is same like the varistor symbol, and will be connected between our AC supply and our grounding lah. So this is for the switching spark gap. And then lastly is for the connection of this, which is from the secondary unit AC, must be terminated at VM1 of the frequency converter and the picoscope. So basically I will explain just like this. So we have the secondary unit, and I draw like this lah, like this, the secondary unit, and we have the banana connector, which is the banana connector, and we have the T junction. So basically the T junction will be just like this. So one of the T junction, one point of the T junction will go directly to our picoscope, 3000. So the picoscope is where is the picoscope? I think I found in here for the picoscope. Oh, there is no picoscope. It is the picoscope located in the so this is our picoscope. So I will snipping tool, copy, and I will be paste in here. This is our picoscope, which is will be connected either one into this lah, this one, by using the coaxial cable, and then coaxial female coaxial cable. Why? Because this T junction is by using the male connection that will be connected to the female of the coaxial cable, and the last one, the last T junction that will be connected to our frequency converter. Okay, for the frequency converter, it is we have one slot in here, show the VM1, so it will be connected in here also. So this is for connection between the coaxial cable, the point of the female coaxial cable, and this is for the directly to our frequency converter. So let me find the VM1. So this is our previous lab, so there is no in here. So I cannot found here. Okay. for it. So basically, okay, no. Okay, in here, I mean. So this in here, snipping tool. Copy, and I will paste in here. So basically, the connection of this T junction we directly to VM1, VM1, which is in this VM1 we have two slot, VM2 also two slot, and we have V3, VM3, VM4, VM5, and VM6. So basically for the VM1 and VM2 is for the AC connection, and the rest of the connection of VM3 until 6 is for the DC lah. So that's for the connection of the secondary unit by using the banana connector and the T junction that will be connected into the our picoscope and to our frequency converter of point of the VM1. Okay, next I will explain all the connection of the of this laboratory, which is the firstly I need to clear this window, and then basically it will started with the like this with the our test transformer. So and then from this transformer we have the connection rod, which is made up from the aluminium rod that will be connection between the our what we call is the measuring capacitor that by using the connection cup, and at the top, and also at the top of the measuring capacitor we also have the top electrode, which is the top electrode, and we have the floor pedestal, and then at the floor pedestal we have the what we call as the grounding switch. So this is the grounding switch, consists of the grounding rod. So the grounding rod will be touched between the within the top electrode. Okay, next we have the secondary unit. This secondary unit, draw like this lah. The secondary unit. This secondary unit, as like I said before, there is the banana connector and the T connector, which is with this T connector we direct to the picoscope, our picoscope, and then we have the one another part of the T junction we connect to our frequency converter, and then also for the grounding purpose is there is the point between all of these component, which is this point and this point at the floor pedestal, that will be connect each other by using the cable and the copper braided that will be connected to our secondary part lah. So that is for the full connection of the okay. For the section C, I already watched the video that for the what we call the safety rule. What comment I can give this video, that the surrounding of the workspace is very messy, and then the gate is not closed completely. And then for my suggestion, we need to make sure that all the what we call the workspace, our workspace is must be arranged very carefully in order to make sure there is no cable that will be placed everywhere, which is we need to, kita tak nak bagi kita kita tak nak bagi bila keadaan tu dah messy, it's very messy and can make our life in danger. And then the suggestion for that I can make is we need to make sure all the we need to close the gate before we run our testing. So that's why we must always think for the double safety, which is very danger for our life when we use the HV lab, which is very danger. So that's all for my video for the lab test. That's all from me. Thank you.